wishes to everyone. Welcome to my video. My name is Dr. Ayan Devnath. I am an IIT Delhi alumni. I have total 8+ years of experience in the field of data science and AI. We also use RBF kernels. What is RBF kernels? Let me explain you. RBF radial basis function. This is the mathematical formula of radial basis function RBF, where x1 and x2, this one x1 minus x2, what is this? This finds a distance between the 2 points, and this is find out in terms of Euclidean distance. This is Euclidean distance. There are defined way to calculate the distance. We also know that there are distances like Manhattan distance. Manhattan distance is actually the absolute value of the difference between these 2 points, and when we consider with respect to the square of the value means, suppose there is one point A comma B, there is another point C comma D. So if we take the difference of these 2 points in terms of Euclidean, it is like A minus C plus B minus D. This will give you the value of the Euclidean distance. This will give you the value of the Euclidean distance. What is Manhattan? For Manhattan, we take simply A minus C plus of B minus D. This gives Manhattan. Right. So here we are using Euclidean distance, not the Manhattan distance. We can also write this formula as where this is sigma is the standard deviation. So here in this case, this gamma is a hyperparameter. We need to tune this value of gamma so that we get a very good radial basis function or RBF for a particular set of data. We need to tune it for different data set. It will be different because the hyperplane will be different. So we have to tune this value of gamma so that we can get a base suitable RBF to classify different points. Okay. There is one more kernel function which is sigmoid. What is the mathematical formula? I am writing it here. In this case, gamma and R are two different hyperparameters. Okay, so this is sigmoid kernel function. I am going to tell you these things again and again, that without knowing the theoretical background of SVM or kernel anything, you should not use by just importing the Python library blindly, because in that case you will not get good accuracy. You will not be able to know what is actually happening. You will get some accuracy, you will have a data, and on the data you are just using a classifier, but you will not able to get a proper model. Okay, because while you are importing, what you need to do is that we are using a scalar library in Python. We are using this, and what you have to write is that import SVC. SVC is support vector classifier equals to SVC in bracket. What we write? We give the kernel. Say we are giving it as RBF. So in Python script, what you need? You just need 3 lines. Okay, first line, from scalar library you are importing support vector classifier, and then you are like then you are using this SVC using a kernel. It can be RBF, poly or anything, and then you are creating a model, and this model is used to fit your extend data and y-trend data. So you just need 3 lines. But what you need to know is that what is the thing or the maths or the like the operation behind it. When you know these things, then you can tweak the parameters here accordingly. You can do hyperparameter tuning also, and you will be able to know which kernel should we use. You have the flexibility to know what is actually happening. You will be not using blindly, and when you have this flexibility, then you can grasp the concept well, and you can really play with the data and machine learning models, and you will be able to learn in a better way, and you will definitely find that your model is improving, your model is giving better accuracy, and you will end up being a better data scientist. Okay, I hope you enjoyed my video, because in this video I have explained a very important concept, SVM kernel. Hope you see all of my video to know from the introduction to the mathematics to the SVM kernels, and I am going to make one more video for the implementation of the SVM using code. Okay, till then, see you.